So let's talk about limiting reactants then. As a foreword to this is a process that we're going to need to follow anytime we have quantity information about multiple reactants. By contrast, we do not need to use this process if we see the words excess or equimolar in the problem. Those two words indicate that we have an extra amount of one of our reactants, and so we don't need to worry about that one running out. And so we're going to assume that the one that is not in excess is going to run out at some point. And so that's going to guide the amount we can make. If you took the previous intro chem and used the textbook that I co-wrote, you'll remember seeing a video of me making sandwiches. Absolutely delicious. I believe they were just tomato and lettuce sandwiches or something like that. Really lovely, right? The idea was, for that, is we have a limited amount of ingredients, right? And depending on the proportions of those ingredients used, we will run out of one of them before we can use up all the rest. And the same is true in chemistry. And in order to simplify this, we're going to start off by simply looking at moles to moles. We won't worry about grams right here. So, if we take that same reaction from last time, we have our hydrogen and nitrogen combining to make ammonia. If we say we have 5 moles each of hydrogen and ammonia, and hydrogen and nitrogen, we have 5 moles each, we can determine which one will run out first. And actually, this is a bad number because 5 would not evenly work out. So we'll use 6 instead. So if we have 6 moles of each, we can see how much we're going to use of each one. We're going to want to do our stoichiometry process for each reactant. Or, since we are given moles, we know that we can just go directly from moles of one substance to moles of another using the reaction coefficients. So, we can go ahead and let's do the write-out for this, and then I'll show you an easier way using a table. So, if we have 6 moles of hydrogen, nitrogen, we'll do nitrogen first. If we are going to react this, we have 1 mole of nitrogen is our coefficient, 2 moles of ammonia is our product coefficient, and so we will make 12 moles of ammonia using all of that nitrogen. Now let's see how much we can make with the hydrogen. If we have 6 moles of hydrogen, we have 2 moles ammonia on top and 3 moles hydrogen on the bottom. These are our reaction coefficients. We're going to end up with 4 moles of ammonia. And so, what this means is that one reactant, our hydrogen, can make 4 moles of ammonia, and the nitrogen can make 12 moles. So what wins? Well, if we're limited by one of these reactants, we will run out of it. And in this case, that's going to be hydrogen. We're always going to choose the lowest amount of product possible. The reason for this is because that reactant will run out first. It will dictate the maximum amount we can make. If one reagent says, yeah, we'll make 12, the other reagent says, no, I can only make 4, then 4 is the answer. Doesn't matter how much more nitrogen you put in there, you're not going to be able to produce more ammonia because you have no hydrogen left. And so that's the idea here. One of your reactants will run out. And so ideally, you'll do this process for everything. But if you're given just moles, you can simplify it a little bit by using what's called an I delta F table. We have the initial we have the change, and then the final amount remaining. So that is our initial, change, and final amounts. And so we saw that hydrogen is going to run out. So we're going to use all 6 moles of that. And so we're going to be left with no hydrogen. And we're going to make 4 moles of ammonia. So we're going to end up with 4 moles of ammonia at the end. But what about the nitrogen? How do we know how much we're going to use? If we know we're going to have extra nitrogen left over, because the hydrogen will run out first, how do we know? Well, one way to do it is you can take that 4 moles of ammonia and calculate using the coefficients to figure it out. I'll show you another way. If you take the amount you did make, I'm not going to say actually because we're going to see that in another video, amount that is limited over your amount that could be made using your reagent. In that case, that's going to be 4 moles over 12 moles. That's 1/3, right? Multiply this number by your starting amount. Let's see where I can put this. Multiply this by your initial amount of your excess reactant. This is all for the excess, right? So if we had 6 moles to start, we're multiplying that by 1/3. That tells us we have used 2 moles. And again, we could have calculated this by going backwards. We could say, okay, well, we know we made 4 moles. This way will be easier, by the way, once we start bringing in grams, using this amount that you did end up, that you could make with your limiting reactant, over the amount you could make with your excess reactant. You can do that with grams as well, so you don't need to use moles. And so it'll be easier once we use grams. But for right now, moles is just as easy to do it this way. We can say the amount that we could make by our limiting reactant, we can just convert this back into nitrogen using dimensional analysis. So we would see indeed we would still have 2 moles used up. All right, and so if we have used up 2 moles, we will have 4 moles left of ammonia. I'm sorry, of nitrogen left. So at the end of this reaction, we will have 4 moles of nitrogen and 4 moles of ammonia. We will have used up all of our hydrogen. In another video, we're going to do another example, and this time we're going to use masses. So in order to summarize this one, though, whenever you're given quantity information of 2 reactants or more, you'll need to do this process. It kind of works out to do, you can do this table with moles, if you want to convert everything to moles. You can do a table like this. You can also do the stoichiometry. You can say, okay, well, I'm going to take 6 moles and figure out how many product moles I can make. Once you do that for each reactant, you'll always choose your smallest number. That's the amount that you can make in theory, and that's it. Can't make more than that. Once you have that information, you can use it to determine how much of your excess reactant you have used up, and then from that you can determine how much is left over. And so with this, that's how we can work through this. If you're just given moles, though, if you want, what we can do also is just look at the coefficients and just mathematically determine it because it's pretty easy to do. If you have the same amount of nitrogen and hydrogen, but you use 3 times as much hydrogen, you should run out of hydrogen first. So you can go ahead and use all of it right away. And then, of course, all of that hydrogen would become your product, the ammonia in this case. And if you're using 3 parts hydrogen to make 2 parts nitrogen, each part would be 2 moles. And so you can predict how much you can make without having to do the stoichiometry. That's how it works for moles. With grams, it's a little bit more tough. It's harder to do this kind of very easily, kind of in your head like that. So we'll take a look at that in another video.